Problem number 39. Show the line integral it's given here is independent of the path C, and evaluate if C is any path from 1, 0 to 0, 2. Path independence, the integral being path independent, means that the vector field f here is conservative, f being 2x sine y, comma, x squared cosine y minus 3y squared. What does it mean for this vector field to be conservative? Well, okay, so it's defined everywhere in the plane. The plane is simply connected here. So it means that it has a potential function. We can also just, to show that it's conservative, we can, from the get-go, just check that it's conservative by doing cross-partial derivatives. So I call this m and this n here. We need a partial derivative n with respect to x needs to equal the partial derivative m with respect to y. Partial derivative m with respect to x is going to be 2x cosine y. And the partial derivative m with respect to y is going to be 2x cosine y. So this checks. Okay, so now we need a potential function. Now we need potential function. How do we find the potential function? We're going to integrate the term m here with respect to x. We're also going to integrate the term n here with respect to y and combine. So the derivative of this, the antiderivative of this with respect to x is x squared times sine y plus not a constant but a function that maybe depends on y, because the partial derivative of this with respect to x would be 0. Antiderivative of this with respect to y would be x squared sine y minus y cubed plus some function that potentially depends on x. So combining this together, we have x squared sine y in both of those. And then we have a negative y cubed. You might not see the negative y cubed explicitly written up here, but it could be part of that C1 of y. So here's a potential function, and we want to find all potential functions. We could add a plus c here, but we just need one to make this work here. So this is our potential function. Okay, so great, we know that this vector field is conservative because here we found this potential function down here. So that means that this integral up here is path independent. That means that the integral over c of 2x sine y plus x squared cosine y minus 3y squared dy, this is equal to, if c is going from 1, 0 to 0, 2, this is going to equal little f, our potential function, evaluated at the ending point, minus little f, our potential function, evaluated at the starting point here. And so what do we end up with? Okay, let's just plug stuff in here to x squared sine y will be 0 squared times sine of 2 minus 2 cubed, that's f of 0, 2, minus f of 1, 0 will be 1 squared times sine 0 minus 0 cubed. And this is negative 8. So it does not matter which path you take from 1, 0 to 0, 2, because this integral is path independent, which follows from it being conservative, and the conservative follows from the cross partial derivatives check and finding the potential function for it. We can just evaluate this vector line integral by evaluating the potential function at the two endpoints.